Hello, and welcome back. This is section 6, and this is a section about volume of prisms. Okay, so we studied in the last section what a prism was, and we'll kind of revisit that. But we're going to talk about the volume of prisms, okay, today. So our objective is we want to write expressions to represent volumes or unknown measures of right and oblique prisms. We want to calculate the volume of an unknown measure of a right prism based on a mathematical or real-world model. And we want to be able to do the same thing for an oblique prism. Okay, so first of all, what I want to talk about and really stress today is what is the base in a prism, and when will that base drop? Okay, if you're into the whole dubstep thing or whatever. Okay, so what I want to talk about is this base area. Okay, the base area is the bottom. Okay, so let's talk about the base is the bottom piece, okay, typically the bottom, all right? And in this example, it's not the bottom area, okay? And this is where a lot of people get confused, is that knowing that this area of this figure, okay, this base of this triangle, okay, is your base, okay? The base is the bottom, okay? And there are parallelograms that, and it's kind of hard to say this, but parallelograms that are, I guess, coming out of the base. Okay, and so let's kind of talk about, let me show you an animation on how we kind of get these base shapes, okay? So if I were to take these, if you will, like pieces of paper or like small little cardboard boxes and stack them on top of each other, okay, that's how we get a prism, okay? That's the idea, all right? And I'm just going to kind of replay this video a few times and show you that that's how we get that. And so, as you see these pieces drop down, okay, let me pause this real quick. Notice that like the shape that's hitting the ground is your base shape. And that when you keep stacking all these pieces on top of each other, what you end up creating here is a parallelogram, okay? And so that's what I mean by parallelograms coming out of the base, okay? It's that idea. All right, so that's the idea. All right, so the base area, especially on, and let's put a little star here, on a triangular prism, the base is a triangle. Okay, so a triangular prism, the base is a triangle. Okay, a lot of people get screwed up and they think that EFDC, this part down here, is the base. Okay, but it's really this triangle that's your base. All right. So now, what we want to talk about, the volume is, what is volume? Okay, we talk about it, but what is it? Okay, and it's the measure of the amount of space occupied by a three-dimensional solid object. Okay, so again, here's your base figure, okay, NOYX, okay, and what we do with that figure is we give it depth, okay. We have this area of the base, and what we have is we want to give it some depth. All right, so what we do is we actually take these values and we make them bigger, or we bring these values up, these lines up, and then what we end up getting is we end up getting another shape. Okay, if we bring that up and extrude that up, we get an actual three-dimensional shape. Okay, and so the volume that we get, okay, the formula for volume. All right, let me write this down. The formula for volume is V is equal to B times H. Okay, now B is the area of the base. Okay, so that can vary depending on what kind of shape you have, but B is the area of the base, okay? And H is equal to the height of the prism, okay? So for example, if we look over here, on these figures, you have this base area here. Your height is the line that's coming out of the base, okay? Same thing here, okay? Here's where it gets weird on this triangular base, is that here's your base area that's the triangle. Here is the height of that triangle, okay? So it's kind of being of what's been extruded up is your height, okay? All right, so now what we want to do is we want to find the volume of prisms with different base shapes. Okay, now remember what we're doing is we've got the volume is equal to the area of the base times the height. Okay, and the height I'm going to denote in red. Okay, so the base here, okay, on this prism over here, the base shape is a hexagon. So this is a hexagonal prism. Okay, so my base, and I'm going to denote my base in blue. Okay, I'm going to kind of just outline that. Okay, so my base area, or my base, is this figure here. Okay, and that area is 16 inches squared. Okay, and then my height is this length here, which is 20 inches. So then my volume, okay, is going to be 16 inches squared times 20 inches, okay? Now, if I take 16 times 20, that's going to give me, let's see what that gives me, 16 times 20, that's 320. Okay, so my volume is 320. Now, I've also have inches squared times inches. Okay, now the unit of measure that we get for volume is cubic, okay? So 320 inches cubed, all right? So volume, we deal with cubic measurement, okay? When we were talking about area, dealing with a square measurement. That's why we have the little 2 there, okay? Let's go over here to the next one, okay? On the next one, all right, they give us a shape. I'm going to denote my base in blue. So this is my base, the triangular base, okay? And then my height, and that base is 14 centimeters squared. My height is this distance here, and that's 15, okay? So my volume, okay, for this is going to be the area of the base, which is going to be 14 centimeters squared, and then times 15 centimeters, okay? So then my volume, we're going to do 14 times 15, and that's going to give us 210. So I'm going to get 210. And then I've got centimeters squared times centimeters, okay, which is going to give us centimeters cubed. So I have 210 centimeters cubed, and that's going to be our measurement for that volume. Okay, so not too bad if you are given those measurements, but guys, a lot of it is your ability to identify what the base is and what the height is, okay, and go from there. Okay, on this one we want to write the expression for the volume of a prism. Okay, so let's take a look at this guy. I have a triangular prism, and let's just really quick do this. I'm going to do volume is equal to the area of the base, and then times the height. Okay, so I'm going to quickly come over here and highlight where my base is, okay, and then I'm going to denote my height, okay. So my base area is a triangle. My base is a triangle. Base is a triangle. So the area of that base is going to be the area base times height divided by 2, or we could write that as 1/2 times base times height. Now notice how I'm using base twice. This is a little b, this is a capital B. This b, remember, is the area of the base. Okay? So I can come over here. If I really wanted to find b, okay, the area of my base, okay, I'm going to say 1/2, and I'm going to use 2x as my base measure, okay? So I'm going to call this 2x, 2 times x, and then times this value, x plus 1, which I'll call the height of my triangle. Okay? So remember, guys, I'm not talking about the height of the prism. I'm talking about the height of this little base here. All right? So now let's talk about that. I'm going to write that as the quantity x plus 1. So now, when I take 1/2 times 2x, 1/2 times 2, these 2's are going to divide out. All right, so the area of my base, b, is going to equal x times x plus 1. Okay? And then if I distribute that x here, the area of that base is going to give me x squared plus x. Okay? And that's that value there. Now my height of this prism, h, is equal to just x. It's just this value here. Okay, so let's put it all together. All right? So my volume, okay, volume is equal to, remember, the area of your base and then times the height. Okay, so volume is going to be, and this is, what is it, x squared plus x. Okay, and then we're going to multiply that by x. All right, so I can, again, distribute this x here, okay, into each of these, and I'm going to get that my volume is going to be x squared times x, which is x cubed, then plus x squared. Good morning, Jim. How are you?
Great.
I had a rough start to the morning. My landlord called me, and she wants me to pick up all the trash and do all this stuff because they're showing the house. You know, I have my girlfriend. She wanted me to trim up the beard, so I did that this morning. So I've had kind of a rough morning. How are you?
Will be on film?
This is on film. We're talking.
Oh, we're still recording?
Yes.
Huh. Well,
Something you like to say into the camera?
have a great day and learn a lot of math, ladies and gentlemen.
Word.
Yeah.
All right, so what you have is you have this formula for the volume in terms of x, okay? And one of the things they want us to do is they wanted to say, if x is equal to 2, what is the volume of the prism? So let's plug in 2, okay? So let's do that. Let me change up colors here. So my volume is going to be equal to 2 cubed plus 2 squared, okay? And I know 2 cubed is 2 times 2 times 2, which is 8. And then plus 4. So my volume, okay, is equal to 12. Now, we got to put a label on this, okay? We're dealing with a 3-dimensional figure. So that means I have, and our measure is centimeters, okay? So this is going to give me centimeters cubed, all right? And that's what we're doing, okay? So that's the volume given that x is equal to 2. Now, the question is what does this length represent right here? Okay, this is just this other side length, this edge length, that's x plus 3. We don't really need it because it doesn't help us. Okay, remember we were just trying to find the volume of the prism. Base times height, okay, gives me the area divided by 2, and then multiply it by the height of the prism. This is the height of the prism, okay? So, all right, let's take a look at another one. Volume of a prism in a real-world context. Okay, Caitlin is constructing a box in the shape of a rectangular prism, so that means that my base is a rectangle. So that tells me that my base is a rectangle, okay, to hold her lab supplies. To sit on her locker shelf, she needs the base box to measure 6 inches by 5 inches, okay? And then it says, if the box must accommodate 90 cubic inches, how tall must it be? Okay, so we're solving for the height. Okay, we know that the volume is equal to 90 inches cubed. Okay, so now, let's again, go through and use our formula. So volume is equal to the area of the base times the height of the prism. Okay, so the area of my base, B, is equal to, and I'm just going to highlight my base here. Okay, to find my base, that's going to give me 6 times 5. So 6 times 5, that's going to give me 30. So 30 inches squared, okay, is my base area. Now my height, we don't know. Okay, and this is the height of that. We don't know what that is. That's what we're trying to find. But we do have our volume here. It's 90 inches cubed. So I'm going to use my formula here, plug these values in, and we're going to solve for h. Okay, so for volume, V, I'm going to plug in 90. Okay, that's what my volume is. All right, so 90 then is equal to my base, which is 30 inches cubed. So I'm going to plug in 30. Okay, and then times h. Okay, now I don't know what h is, but I can solve for h. It's the only variable that I don't have. So, so let's do that. Let's plug in, let's divide both sides by 30 here. Divide by 30. These divide out. Now 90 divided by 30 is 3. So my height is equal to 3 inches. Okay, now remember, I was solving for a length. A length is a one-dimensional piece. That means I have a 1, it's just an inch. Okay, not inches squared, not inches cubed. All right, moving on. Let's talk about oblique prisms. Now, an oblique prism means that whose lateral faces, these faces here. So here's my base. All right. Okay. Means that my faces, so that these faces are not perpendicular to the base. Okay. So the height of the prism and the edge have different measures. So here's the edge. So if I were to talk about the edge of a prism, okay, that's these values here, okay? Now these are not the height. Okay, the height of the prism is the distance going down that's going to be perpendicular, okay? So we've got to make sure that this measure here is the height, all right, and that we don't get confused with that if it's an oblique prism, okay? So let's go take a look at an example here. And it says a piece of crystal is cut into an oblique rectangular prism, okay, with the measurements of ES as 6 centimeters. So I'm going to come in here, all right, and it's let me do this. Okay, we have a rectangular prism. All right, that means that that's a rectangle. That means that our base is a rectangle. Okay. So I'm just going to highlight our base here. Okay? And so we know that ES is 6 centimeters. So I'm going to come over here and call this 6 centimeters. Okay, I know that RE is 8 centimeters. And I'm getting all this information from this list over here. Okay, this is 8 centimeters. All right. ZD, that value, is 14 centimeters. Okay, now I'm going to highlight that in red because that's my height because it makes a right angle. So my height is equal to 14 centimeters. Okay, and then it tells us that CS over here, this length here, sorry I've kind of written all over it, is 15 centimeters. Does that help us in any way? It really doesn't. Okay, this is 15 centimeters, but we don't need it. Okay, this is kind of unnecessary information. Okay, we want to make sure necessary. I spelled that wrong. Oh, God. Don't have spell check when you're writing by hand. So, all right, we'll look it up later or something. You guys can let me know what the spelling is. But this length doesn't tell me anything. Okay, I'm only concerned about the area of my base and the height of my prism. Because remember, our volume is the formula, the area of the base, times the height of my prism. Okay, now the area of the base, B, this can be figured out by multiplying 6 times 8. Okay, so 6 times 8 is going to give me 48 centimeters squared. Okay, and then my height has a measure of 14 centimeters. Okay, so I plug all this in. Volume is going to equal 48 centimeters squared times the height, which is 14 centimeters. Okay, so if I take 48 times 14, okay, that's going to give me 602. Okay, so 672, and this is centimeters cubed. Okay, and that's how we calculate the volume of a figure. Okay, so remember, you know, an oblique figure, prism, we want to make sure that the height is the vertical length that's perpendicular to the base. Okay, hope you enjoyed this video. I had a lot of fun making it. We'll see you later. Okay, bye.